Hey, everybody. I'm Michael Holdmann, founder of PraSaga. This is David Beberman, my co-founder and CTO. I'm the CEO. He's the brains. So everything I say, he'll correct me on as he goes through it. We are part of the Digital Twin Consortium and have been part of it since its inception. Basically, we were part of the IIC back in the beginning as well, when that was formed in like 2015 or so. What I'm going to do is first show what we've been doing for the past 7 years, what it does for you through a use case, and in this case, it's going to be automotive supply chain on a blockchain. And there was a problem statement that was brought out. We're actually introducing the third data model to blockchain, which is a meta-class object state database data model. Bosch Engineering and Business Systems put out a problem statement in 2021 asking, can they ever do an auto supply chain on a blockchain? Because up until this point, and even today, the only thing you can achieve is really simple track and trace. I know where it was, and I know where it goes. You put a QR code on, you scan a part whenever it changes location, but the metadata isn't there, and composability between multiple different parts is very difficult to do with smart contracts. They wanted to solve for three problems. The first was they wanted to have a reputation score for suppliers. Second, if they receive a part that does not meet spec, they wanted to be alerted to it so they wouldn't put it into the vehicle. And the third thing they wanted to solve for is they wanted to have provenance of the end unit. They wanted to have a full audit trail of all the parts, all the components, all the certificates proving that all the parts and components made spec in order to be in there, as well as all the distributors, manufacturers, and everything, all the way down to the raw materials being taken out. So let me hop in here, and I am going to walk through this. Does this work? And maybe I'm not going to do this. Huh? Did I go to automatic? Yeah, okay. And why is this going without me touching? Or is it? Okay, so I can show, well, at the round table, we can go through, it's a YouTube video and I can kind of walk through it. So what we have, or what we are, we're a Swiss nonprofit foundation out of Zug, Switzerland. We also just opened up a 501c3 here in the United States. We're starting to work with UNLV School of Engineering here and some other aspects that we have going on. We are an available source global software stack. We're a software tech stack. And one of the things that we are doing with DTC is we now have a tiger team underneath Dave Shaw's Fintech Group. And the call out here is to get people to start to participate and help us create what we call these class inheritance trees, which Dave will give you an idea of what those are. So let me go into what RWA is. So first of all, RWA, real world assets. Currently, the definition for real world assets hangs around fintech, bond markets, stocks, IP, and so forth. It's projected to be a $16 trillion market by 2030. BlackRock alone committed to putting all 10 trillion of their assets under management, what they say, tokenize those things on a blockchain. And there's a difference. So we don't have tokens. We have classes. We have objects. Tokenize RWA. It's an economic term, the real world asset is, and it refers to any type of asset, physical or digital. They really focus on commodities, physical art, real estate and such, but not those real assets that we start to include in. Fuel injectors, caps on cosmetic bottles, certificates proving that you have all of those things that, that you meet the spec that the manufacturer puts out. One of the things within the demo is you can have a global name, because it's a global namespace, you can have a global marketplace now. And any parts that you have out there have certificates attached to them. Well, they will not, it's not that they receive the part and have to be alerted to it. If the certs for that part do not meet spec that the manufacturer puts out, it's not even available for the manufacturer to acquire. However, they could have another model that actual production run does meet spec, and it would show up in the marketplace for them. So there's a lot of things here: HASI, immutability of data, the security, and all of those things that go along with the blockchain, and the things that are make it beneficial to enterprise and industry. So analysis predict, again, this is going off of just the fintech, but it's market transparency and liquidity. You get frictionless settlement infrastructure. If you can settle a transaction for anywhere in the world within 30 seconds, and it costs sub 1 penny, well, that's a very good cost savings for enterprise and such like that. And it's also producing a heck of a lot more. I know that we do talk to some mines out of South Africa, and sometimes it costs them up to $10 per transaction. It can take up to 6 days to get through, depending on how many different banks it has to go to and such. So the programmable smart assets is what we call these, and these are it's a meta class system, and Dave will kind of show you some diagrams what that means. We are a layer 1. We are a sharded blockchain. Dave designed it as a multi-core processor. The thing that we had to figure out is if we're going to have multiple shards or multiple cores, how can we do execution or processing in parallel? The only way to do that is to guarantee the data independence of each transaction on a shard. And that's why this this new data model was brought up with. So we have a global object namespace. We have a stabilized method of exchange. One of the biggest issues with in blockchain, and especially with cryptocurrency, is the fluctuation of the in price, the volatility in the price. So as long as an industry or a company or a person can trust that if they accept something today, it's going to hold the same value tomorrow when they go to use it, that's where it starts to become relevant and acceptable in industry. Characteristics of what this is: we have both long-term security, which is a proof of stake. We have short-term security, which is proof of work on the long-term, proof of stake on the short-term. Proof of stake is all signatures. It's not long-term security, because what if somebody gets a signature somehow down the line? You can start a new block and build past. And then the other thing that's very, very interesting and important is a consistent average global transaction latency independent of the demand that's coming onto the network. And that's one of the things that we had to solve for. And the first, you now have an immutable audit for any object, cradle to grave. Every transaction that ever happened on anything is now recorded in an immutable database from cradle to grave. I was speaking to Doug, I don't see who didn't make it out here, from Eli Lilly, and after showing him that little automotive demo, he just said immediately, "You just solved my problem for compliance," because there's nothing that they could come out with that I would not have access for auditable data to immediately at my fingertips. And that's the biggest part of this on here. I'm going to stop there, which I think I gave Dave a little more time than I was going to. And we'll let Dave Beberman take over and kind of clarify those things that I was saying now.
Good afternoon. We'll see whether I manage that. I'm going to try to tease you about our technology so you come join our Tiger team. Before I do that, one quick thing about our business model, because you kept saying we don't have a business model. We don't have anything we can sell you, nothing you can buy from us. This is literally an open source blockchain. All that'll happen is if you run your own nodes, just like any other blockchain, you will get your own rewards from it, and you can use it as anything else. What we spent is a whole bunch of time on trying to make blockchain that solves specific things to make a more general purpose. I want to back up real quickly, explain for everybody who doesn't really know what a blockchain is, that it's actually hash chain first, where the hash of each previous block is included in the next block, so that you can verify all the way back to the beginning that all of the blocks are related to each other. And then in the current version of a blockchain, it consists of transactions against some sort of common state. And then, of course, the additional piece in the crypto world is that there's some sort of value that's common known as a coin that runs the blockchain, and you get reimbursed for validating the blockchain through a consensus algorithm with that. The problems that we address, as you can see here, are blockchain scalability, and we use a data independence model to make that happen. What he mentioned, what Mike mentioned a little earlier, is the usable currency, and I'll get into that a little bit with our monetary policy. I probably won't have enough time to go through the hybrid proof of work, proof of stake model. But again, come join the roundtable and come join the Tiger team afterwards. That's what we're really after. How do I change page?
Down there, right there.
Good. Okay. So every blockchain is essentially a replicated state machine, and when you're talking about the state, you're really talking about a key value flat data store. And so whether you're running a Bitcoin model, which would be called the UTXO model, I'll go into these in a minute, and the Ethereum account model for smart contracts, or our model, which is a first-class, meta-class object state database model. We're a new model for it. At the bottom of it is a key value store where the values are basically raw bytes. The keys for us are 32-byte, 256-bit hashes using a secure hash algorithm that is probabilistically not collision-free at the level of we depend on most of that for our security for all of our keys to start with for private public key encryption. We overlay on top of that an object state database representation. What that means is that the value is actually a well-defined object type, meaning that it'll have fields defined by classes for it. The classes are also objects, which is unique to our model, where the classes are actual objects in the blockchain as well. And the classes, of course, have traditional methods and fields that define what the objects look like. And then we support single and multiple inheritance. Beyond that, though, and this is the part that makes the scalability and really puts our system together, is the account-centric model. So an account is an object that has references to other objects. All the references are really just these keys all the way back to the same key value store, so they're all the 32-byte hashes. You can have any number of accounts. We expect to, of course, support literally billions of accounts, being large enough to support basically the entire world. Making this up as I go along. The key point of why that matters. Why do you care that we have a bunch of accounts? Because you could do this on a single blockchain. Whole point about, and the whole problem we're addressing with blockchains is that they have fixed capacity. So in the Bitcoin world, the Ethereum world, you're fighting for a slot in a block for a transaction. You submit a transaction to it, you're fighting for that piece. Okay, what happens when you have a scarce resource with a fixed supply? We call that like the gas price at a gas station. Anytime over summer the price goes up exponentially because, of course, the amount of oil stays constant. This is literally the same type of problem. So we use what's called sharding to do that by increasing the capacity of the blockchain. The analogy for this is multi-core CPUs, which every one of you is using right now and has in your pocket. The interesting thing about a multi-core operating system is that the first core and the second core and the third core and fourth core, as you go down, the return on investment goes down. What that means is if you have one core, let's call that 100%. If you have two cores, you don't get 200%, you might get, say, 180%, and so on, and it tends to fall off. The reason why is that you have cross-data problems and serialization of data to make sure you're a deterministic system. You can't run it in parallel. What we do for that is to allow for parallel transactions, is to guarantee that the data at any given time, any given block for transactions on any given shard is totally independent of every other shard. The algorithms for that is what's the core of this technology. But what that means is I labeled as imagine there's more like 1,000 transactions per block, but I can't really diagram that. So transaction A on one shard, transaction B on another, those accounts that are being used for that transaction have no relationship to each other, so you're guaranteed that you can run them in parallel deterministically. That's the key of our entire technology. Just to be very clear, when we're talking about sharding, we literally mean multiple parallel blockchains running together simultaneously. But one of the other pieces we add is, instead of having a fixed capacity of the chain, under higher demand, increase the number of shards. So you increase the capacity so that you don't run into the gasoline problem where the demand goes above the supply and your cost goes through the roof. So we're trying to stabilize the cost, which is known as transaction fees of the blockchain. At the same time, by the way, also goes the other way. If demand drops way, way off, you drop the supply down, you drop the capacity down so that the transactions don't go through the floor, because of course it's a fully decentralized, independent, like I said, we don't have a business model. So we don't want people who want to run the nodes to validate the system to suddenly shut down because they're not making any money. So we're also managing not just the currency, but by managing the capacity. And remember, this is all autonomous. I don't mean we, it runs itself. It will reduce the capacity to keep the transaction fees relatively constant. When I say I can't really say constant. On average, they're constant. Did I hit the right one? Oh, I went way too far. What happened here? Oh, there we go. So I want to hit another key piece of ours. So I have an object-oriented system with first-class objects that do multiple inheritance, where you can basically implement anything you feel like, and you do it. You put a class up on the blockchain. Everybody's using exactly the same code. You don't have an SDK. It's all there. You don't have to do anything about it. You can make as many relationship models as you like, and it's a networked, essentially an object network database. That's wonderful. And now I've got enough scalability, so I don't have to worry about overloading my blockchain, and I have ways to maintain stability of it. All that brings us to the problem of, and this is the part where is crypto, which is, how do I make a currency that is relatively stable so that I can use it without bankrupting my company if I happen to be holding some of it and it drops by 50%, or doubles by 50%, and now I'm a millionaire or something. So the standard blockchain models are the Bitcoin model, which is an intentional deflationary model, having every 18 months or something like that, creating a scarce resource. The plus side of that is people got very rich off it. The downside is it makes a terrible currency, because every time you spend even a coin, you're spending all your future earnings. And of course, there's the $800 million pizza story, where early on somebody bought a pizza for like 100 Bitcoin or something like that. And I personally owned 100 Bitcoin at one point, lost the key. It was worth 30 cents at the time. And so I don't even know where it is. So I'm a multi-millionaire Bitcoin dead person. The second one is, of course, the known as constant rate. Instead of having a halving amount, you just keep creating the same amount over duration of coin. And if you think about that, if you're putting it like a drop in a bucket, once there's a lot of water in the bucket, the next drop really doesn't do that much. You tend to have a relatively constant amount. So I have a constant amount of coin. So again, demand, it's a independent of demand, non-responsive demand signals. And the last one is even simpler. Just create it all at once, and that's all the coin you have. So it has zero economic response whatsoever. Obviously, we know none of those things work. They're great for speculation. If you want to go play the casinos, they're out there. I don't know if it's any better than playing them. But anyways, what we did is spend a whole bunch of time trying to figure out how to have a monetary policy that actually is responsive to demand signal. And the way we went about doing that, our solution is to manage against purchasing power, not just the amount of coin that's out there. What I mean by purchasing power is, if let's say a coin buys a gallon of milk, well, the coin actually is being translated to some currency, usually because you're still buying it in dollars or euros or something. And what we want is 10 years from now, that coin to still buy the same gallon of milk. It might be a lot more. That coin might, have to buy a whole bunch more dollars or euros or something to do it, but that's what we're managing against. Where we came up with this is with Dr. Lawrence White, professor of economics at George Mason University. It's based on he's written, I guess, 5, 6 books already. You can look him up on Amazon. He's well-known in this space. We loosely based it on his definition of the gold standard. I want to be clear, that's not anything like Bitcoin mining. It's literally the gold standard historically. It's a really good book to read, by the way. I think it's like $10 or something. He's also our advisor now to PraSaga, and it was great when we actually met him to have him verify that, yeah, this actually works. I already covered what demand signal means, and the only thing you really can do in a blockchain when it comes to managing the cryptocurrency itself is increase or decrease the supply. And most of the blockchains out there normally will increase the supply, but didn't really think about how do I decrease the supply programmatically. So they get together a community and arbitrarily burn a bunch of coin. And who gets to burn the coin stuff becomes arbitrary. And that becomes a really bad way to actually have your business depend on. I mean, anyways, so I can go into more silly things about that. So what we have is our decentralized Federal Reserve style monetary supply policy. What I mean by that is if you look at the way our Treasury and Federal Reserve of the U.S. government works, basically Treasury tax, Treasury creates money, and the Federal Reserve is in charge of minting and sending it to the banks. For us, the banks are actually the validators getting paid for the coin with minting. And so you have a minting rate, a tax rate, and a burn rate, where the tax rate and burn rate are based off the transaction fees for each block. So I now have coin coming in that I can drop into the treasury or throw away. So I have a way to decrease the supply and have a way to increase the supply by minting. What I mean by it's a programmatic system part of the blockchain. We don't control it in the end. And so you have a DAO managing the currency of the system and what they can do is change the parameters of the mathematics that manage currency, and the mathematics are based on a gold standard model, which is based on Dr. White's proof of history of that actually being a stable currency. So that's a really nice way that we've gone about doing it. And it's unique. Nobody's done any of these things. That's why I'm basically throwing these out. And yeah, that's as much time I was going to do. This is a model that we did of historically of what the purchasing power would look like against what actually happened for if we were actually creating currency against the history of the economic growth of things. I think I missed one comment there that doesn't make sense. Sorry. One of the things that makes sense is how do you do the purchasing power against external things? Those external measurements are usually things like CPI, Consumer Price Index, or others, and we have a bank of those that we'll put together, which again feed directly into the blockchain and again become fully automated. And I'm not going to go through the proof of work, proof of stake consensus model details, and that way I am about 5 minutes over. No, I'm actually pretty good. Only a couple minutes over. I was going to give Mike an opportunity to close up, and then we can answer any.
Okay, so just last slide, we'll we can have questions, and again, we're going to have a roundtable and such. Would love to have people come in. We can walk through that auto supply chain so you actually see this working. It was living code. We did take the object model, put it onto Hyperledger Fabric to prove out, yes, we can put a meta class onto a blockchain. We can put objects inside of objects. So you can have an account object, you can have your asset objects, and we can move accounts and objects between shards. So what we're looking for is people to start to join in. The idea is to build standards, international open standards. What we are looking for is industry to help us figure out what those industry class containment trees or class trees are. It's you have parts, you have assemblies, you have sub-assemblies. What's a process flow for a supply chain in automotive and aeronautics on down the line? What is a process flow for a bond market? What is a process flow for logistics? What is a process flow for pharma research when you're going through 1, 2, 3 and on? Build these specific class trees. That way, there's only got to be one line of code globally for a part. You reference, class, part, and then you define what your part is. You have the classes, you can subclass classes, and you can create objects from them. So every part in the world on a supply chain is going to come from the same instance of code that everybody agrees to globally. That's a definition of part. So now we start to have this standard that everybody can agree to and go on. So we're looking for people that go and help us a well-defined open standard environment. We want to join the Tiger team, contribution in opportunities, establish testbed parameters for solutions. Every single one of the working groups in this in the DTC can benefit from this. This is not just for supply chain. So let's get in and start to do these. Let's put together design docs and then give them to the working groups in order to establish test beds. Let's find out, does this really help our enterprise? Does this functionality of here, and does the immutable record of everything that ever happened to anything ever, does that benefit enterprise? And by the way, there is a way to keep all of your data in private, but still sharing your hash of the work you did with the global chain in order to secure your data more. How do you make it more immutable? You share with 500,000 nodes that are saying, yes, this is correct, instead of just the 5 nodes that are in a network. Next thing, to the function open source, we have the functional open source code done now. Dave has completed it, he and his team completed the implementation. He's now going through the final stages of debugging. We have all the code in our GitLab server, and anybody can go in and look at it. Dave will have the README in, and it's just download a Docker container and run it. We use Python for a programming language. We are modifying and hardening it, so it's good for a blockchain, but it's all based on the same compiler and same syntax in Python. And the last is, add any other operational or functional suggestions or sub-projects that we should be doing with this base code. How do we make this that we've spent all this time on better for you, benefit you? And as an open source community-driven project, we're looking for people to help start to define this and test out. And that is our presentation. Oh, yeah, one other thing. This is a Hester Peirce. I don't know how many companies in the world have a sitting commissioner on the SEC that they can publicly quote. She actually calls us a TSA pre-check of the regulatory use of blockchain. Because of the fact I can have a fully anonymous entity. It's a 256-bit string of alphanumeric characters, won't be repeated for billions of years. We check it against the single object state database in order to make sure the number is not done before it's assigned to an object. And then you can have certs in your accounts saying, yeah, I'm an accredited investor or these. Nobody knows that. None of the data is sitting on the blockchain. It's a hash of where you can get access, but only if you have a public key. But the blockchain knows that this person or this entity is allowed to do this type of transaction in this part of the world without anybody knowing who you are or what you are. In terms of that. So it's really bringing what I coined as individual sovereignty, whether it be to individual humans or to individual organizations. How do you become your own sovereign state that can still be shared and have relationships with other sovereign states and work symbiotic? So that's everything. And if anybody has any questions, there's a lot of information there. We'd love to take them. Yeah. Kind of works.
Sound like you were alluding to digital passports.
What network?
The digital passports. Europe is mandated. The EU, the idea essentially of banning all products get manufactured.
Right.
Digital history and products.
Absolutely.
Parts of materials that use those products and then once they're sold, obtained and information, you can make the circular economies. That's like
Yes, what happened is the video that he wanted to present as an example of a supply chain demo that's set up to do that wouldn't play. come to the working group if you want to follow up. Oh,
Gave me a lot of attention in your
cool.
That's the whole point about it, the decentralized digital ID.
He's Mike.
Go ahead.
He's Mike.
You're welcome.
Thanks. Cool.
Yeah, please.
So, two questions. What are you using for the routing of the site? Is it your own?
Yes.
Okay. I'll
Wait. By the way, we're trying not to get very technical with the call, but the P2P part is with lib P2P, and we'll use a gossip sub routine from it. And the direct connections right now are just GRPC, TCP type things. But the consensus algorithms are ours. One of them is a modified HUD stuff, if you know what that is. The other one is literally our own hybrid solution. I don't know what he's saying. So can you get any? I can't get a word of what he's saying.
Huh?
What did he say?
No, I think this is a problem with having two deaf guys up on stage in this sound system.
It's an area of hybrid EOW.
Yes. Yeah, the consensus.
It is hybrid. What is the consensus? The normal program we do proof of work, and based on that, you would have the rules for the US.
I happy to go into detail with it. I don't know a lot of other people here will follow, but talk to me one-on-one. I'll walk you through the whole thing. Yeah.
Anyone else? Well, thank you very much for taking it, for listening to us. I appreciate everybody staying awake.
You already have them open?
Yep, it's just the next slide.